Hello students, most welcome to Dr. Acharya Academy. Today I am going to discuss on the periodic trends and chemical reactivity. This topic has been taken from the NCERT Chemistry Class 11 books. This is the part 1, unit number 3. Today's class number is 062. For previous class, we have observed the periodic trends in certain fundamental properties such as atomic and ionic radius, ionization enthalpy, electron gain enthalpy, and valence or oxidation state. If you go through my previous class, then you will understand these fundamental properties and its relation with periodic trends of elements very clearly. We know by now that the periodicity is related to the electronic configuration. On this topic also, I have discussed in the previous class. So, this electronic configuration, with this there is a relation of the chemical and physical properties. Today's learning point is today we will explore the relationship between these fundamental properties of elements with their chemical reactivity. Atomic and ionic radius, we know already from the previous class that is decrease in a period from left to right. And what will happen? That ionization enthalpy also will increase along the period from left to right, and electron gain enthalpy also will be more negative across a period from left to right. The ionization enthalpy of the extreme left element in a period is the least, and the electron gain enthalpy of the element on the extreme right is the highest negative. You consider one period number 3. Period number 3, extreme left is the sodium and extreme right is the chlorine element. So as per this statement, that ionization enthalpy of the sodium is the least, and the electron gain enthalpy of the chlorine is the highest negative. And this part also I discussed in the previous class, that noble gas having completely filled shell, so it is very stable, and that's why it has positive electron gain enthalpy values, because it is very difficult to add electrons in the noble gas, because the noble gas electron configuration is very stable because of its filled shell. So this result into the high chemical reactivity at the two extreme and lowest in the center. That means in a periodic table, extreme left side, whatever the representative element is there, and whatever the right side, that representative element is there. So these two extreme, I've given an example. The period number 3, extreme left side sodium and extreme right side is chlorine elements will have the high chemical reactivity. The maximum chemical reactivity at the extreme left we know that alkali metals, group number 1 contains the alkali metals, and this maximum chemical reactivity of this group 1 elements is exhibited by the loss of an electron, leading to the formation of a cation, because it has in outer shell only single electron, so it is ready to lose that electron to get the previous noble gas electronic configuration. And that is why it has the maximum chemical reactivity. And the right side for the, as for example, chlorine, the third group, extreme right, that means in general the group number 17 is the halogen group. Outer shell electron number is 7. So this element want to get one electron to get the next noble gas configuration, to get the anionic form singly charged, and that's why it also showed the maximum chemical reactivity. And this property can be related with the reducing and oxidizing behavior of the elements. And this reducing and oxidizing behavior of the elements, that we learn next chapter. Property, this reactivity can be directly related to the metallic and non-metallic character of elements. We know that metallic character means sodium is a metal and halogen, as for example the chlorine, is a non-metal. So this chemical reactivity is directly related to the metallic and non-metallic character of elements. The metallic character of an element which is highest at the extremely left, that means for the group 1 elements, group 2 elements, decrease metallic character, and the non-metallic character increases when you're moving from the left to right across the period. It means that the extreme left side, consider about the period number 3, the sodium, its metallic character is highest. But when we move this period towards the from left to right, then extreme right side in the period number 3, what is the element is there? Yes, chlorine is there. So for this, the non-metallic character is highest. Therefore, from left to right of any period, metallic character be decreased and non-metallic character is increased. The chemical reactivity of an element can be best shown by its reaction with oxygen and halogen. We'll give one example that we'll consider the reaction of the elements with oxygen only in this case. So elements on two extremes of a period, as for example, I have given in the period number 3, extreme left, the element is the sodium, and extreme right, the element is chlorine. So elements on two extremes of a period easily combine with oxygen to form oxides. The normal oxide formed by the element on extreme left is the most basic. It means that when sodium reacts with the oxygen, that means when sodium is oxidized, then the normal oxide, it is the basic. Whereas when the chlorine, that means extreme right side of the period, chlorine react with oxygen, this compound will be most acidic. Oxides of elements in the center are amphoteric. Whatever center means aluminum is there, arsenic is there, these elements, and these are the amphoteric or neutral. You know that 14 carbon is there. Nitrogen is another group number 15. So whatever the oxide of these elements is the neutral. Amphoteric oxides behave as acidic with base and as basic with acids, whereas the neutral oxides have no acidic or basic properties. Now we'll show by a chemical reaction with water that the sodium oxide Na2O is a basic oxide and Cl2O7 is an acidic oxide, to defend our previous statement. So when Na2O react with the H2O, it will form sodium hydroxide, NaOH, and which is the basic in nature. So Na2O is a basic oxide because hydrolysis of Na2O would form one hydroxide or base. Cl2O7, when it is hydrolysis by H2O, it will form 2HClO4. This H means it has the acidic properties by hydrolysis of Cl2O7. So Cl2O7 is an acidic oxide. And this basicity and acidity we can test by using the litmus paper qualitatively. Now discuss on the transition metals. From the previous class we know that transition metals is a 3D series. The change in atomic radius is much smaller as compared to those of the representative elements. Representative elements means belongs to the group number 1, 2, 13, 14, 15, 16, 17 and 18. The change in atomic radius is still smaller among inner transition metals. Lanthanides and actinides series, we know that is the 4F series. In periodic table, we know extreme down to row is to period is there, and this is called the inner transition metals. That means 4F series. Transition enthalpies are intermediate between those of S and P block. S and P block elements, that is the representative elements, and in between these D series elements remain. So that's why the ionization enthalpies are intermediate, because it stays this 3D series or 4F series in between the extreme left S block elements and extreme right in the periodic table P block elements. And what is the result? These transition elements are less electropositive than group 1 and group 2 metals. In a group, the increase in atomic and ionic radius with increase in atomic number generally results in a gradual decrease in ionization enthalpies and a regular decrease. There is some exception in some third period elements in electron gain enthalpies in the case of main group elements. Thus, the metallic character increases down the group and non-metallic character decreases. This trend can be related with their reducing and oxidizing property. Reducing and oxidizing property we'll discuss later chapters. In the case of transition elements, however, a reverse trend is observed. This can be explained in terms of atomic size and ionization enthalpy. This class is very helpful for you. I have the podcast channel in the same name, Dr. Acharya Academy. You can go through for honors and degree chemistry level education. Thank you so much for watching this class.